factorization of algebraic expressions. We have about 3 different types. So let's look at the first type. The first type is common factors. We factorize common factors. Now, in this type, you look at the highest common factor, then you bring it outside the bracket. That is all. So let's look at this to make you understand. So here we have this expression and we are asked to factorize. So let's look at the highest common factor. So here we have 5 as a factor here, 5 as a factor here. So we factorize the 5. And then what else do we have as a factor? We have x, and then we have x here. So we also have x being the highest common factor for x. And then y, we have y squared to be the highest common factor for y. So here, what is left here is 1 minus, this now becomes 5, and then x squared. So we have factorized. Now, opposite of factorization is expansion. When we expand this, we get this expression back. So let's look at number 2. So for the second one, we have 4x minus 2x squared is equal to, now let's look at the numbers. The highest common factor here is the 2. So we bring the 2 out. And then x2 is a factor, we bring it out. So here it is left with 2 minus, here is left with x. So we have factorized this as well. Let us look at the third one. Number 3. We have 5a plus b. Now here, we do not have a common factor. So the factorization of 5a plus b is the same 5a plus b. Okay, so the second type of factorization is the grouping method. So in this method, we group expressions and factorize the groups. We factorize the groups in such a way that the terms in the bracket are the same. Then we maintain one of the brackets which is the same, open another bracket to multiply, and then the factors we factorize outside, we bring them in a bracket. As simple as that. Let's look at this. So here we pick them in group. So these are the groups we are talking about. So let's pick this. What do we factorize here? B. What is left here is 5a minus b. We factorize this one. Let's factorize the other one. So we factorize plus 2 plus 2c, because we have 2 being factor here, and then we have c being here. So here we have 5a minus b. Now, so what do you observe here? You can see that the expressions in the bracket are the same. So we maintain one of it, 5a minus b. And then open another bracket to multiply. Then the factors outside the bracket, we introduce them here. So we have what? B plus 2c. We have factorized. Okay. Now let's look at the second one, number 2, which is ax minus 4ay minus bx plus 4by. Again, by the grouping method, we pick them in groups. So let's factorize. Here we have a, we factorize a. We have x minus 4y. Here, what do we factorize? Our main aim is to make the ones in the bracket the same. So we factorize minus b. So here now becomes positive x, And then because we factorize minus, here becomes negative 4y. And again, the terms here in the brackets are the same. We maintain one of it, x minus 4y. And then open another bracket to multiply. The one outside here, we introduce them, a minus b. We have factorized. Still under the grouping method. Here, sometimes the expression when given, you need to regroup in order to factorize. So how do we regroup this? Here, we say, let's regroup all the a terms and then the b terms. So here we have a lx. Where again do we have a? Plus a my. Where again? Plus a n z. So let's come to the b. Plus b m y plus b n z plus b l x. We have regrouped it. So now let us factorize. So here in factorize, we factorize a. So a, then we have lx plus my plus nz. Here we factorize the b. So plus b. We have my plus nz plus lx. Now, when we look at the expression in the brackets, they are the same. Lx, we have Lx. My plus nz. So let's maintain one of it. So we maintain Lx plus my plus nz. Open another bracket to multiply. Then the ones outside, which is a plus b factorized. Again, under the grouping method, let's look at this. Here, we factorize the p. So we have p into x plus y plus 2. And then here we factorize the q. So plus q into 2 plus x plus y. Let's look at the expressions in the bracket. They are the same, x, y, 2, 2. So let's maintain 1, x plus y plus 2. Open another bracket to multiply. Then we have p plus q. The type 3 of factorization, we have the quadratic trinomial. Trinomial is an algebraic expression with 3 terms. Trinomial, 3 terms. An example is this, which is quadratic expression. So how do we factorize? What we first do is that we multiply the variable square term by the constant term. So in this case, it gives us 12x squared. Now, then we look for 2 factors of 12x squared, which when we simplify, it will give us the middle term, in this case, plus 7x. 12x squared has many factors, but only 2 will satisfy this. Let's look at this. We have x, 1x, and then what? 12x. These are factors of 12x squared, yes. But when we simplify, it will give us 13x. So this is 7x. So these are not the required factors. Let's look at another. Minus x, minus 12x. This one, too, are factors of this. That is, negative times negative will give us what? Positive. But when we simplify this, it will give us minus 13 what? X. Another factors of this is minus 3x, minus 4x. Yes? But when we simplify, it will give us minus 7x. This is what? Plus 7x. So let's look at another. 3x and then what? 4x. These are factors of this. Let's simplify 7x. So you see, these factors satisfy this. So what do? We rewrite this. In place of this, we introduce these 2 factors. Plus 3x plus 4 and then plus the 12. Now here, we group them. So we pick this one and this one. We factorize x. So we have x plus 3. And then here, what do we factorize? We factorize plus 4. Sorry, this is x. I omitted the x. So we factorize plus 4. So here becomes x plus 3. The terms in the bracket are the same. Let's maintain one, x plus 3. Open another bracket to multiply. So we have x plus 4. Okay. Now let's look at the second one, number 2, which is 3a squared minus 9a minus 12. Again, we have to multiply the variable squared term by the constant term. So minus 12 times 3a squared gives us minus 36a squared. So what are the factors of this, which when we simplify, it will give us the middle number. So we rewrite a squared and then we place it. Now, the required factors are plus 3a and then minus 12a and then minus 12. Now, let us pick them in pairs and factorize. So we factorize 3a. Here becomes a plus 1. Here we factorize minus 12. So this becomes a plus 1. Why plus 1? Because we have factorized the minus. So this place becomes what? Plus. So the terms in the bracket are the same. So let me shift it here. The terms in the bracket are the same. So let's maintain 1, which is a plus 1. And then we place this one, 3a minus 12. Number 3, don't confuse when you see this. It's the same quadratic. So we use the principle we have already studied. So we multiply this by that. It gives us minus 90 a squared b squared. Yeah. So let's look for two factors of this, which when we simplify, it will give us the middle term. So in this case, it's going to be minus 5ab and then 18ab. Yeah. So this is equal to 3a squared b squared, then minus 5ab plus 18ab minus 30. So let's pick them in pairs and factorize in groups. So here we factorize a, b. So here gives us 3ab. Minus 5. Here we factorize plus 6. Then here becomes 3ab minus 5. The terms in the bracket are the same. Let's maintain 1. Open another bracket. We have ab plus 6. Again, this is also quadratic. We are going to use the previous principle. So we multiply this by that. So it gives us 90x squared y squared. So what are the two factors of 90x squared y squared? Which when we simplify it will give us minus 33xy. So they are minus 3xy and minus 3xy and then minus 30xy. So let's rewrite this. So in place of this, we bring minus 3xy minus 30xy, then plus 5y squared. Let's group them and factorize. So here, what do we factorize? We factorize 3x So here will be 6x minus y. Here we factorize minus 5y. Why are we factorizing minus 5y? We want the expressions in the bracket to be the same. So when we factorize minus, here will be minus. So here will be 6x minus y. The terms in the bracket are the same. We maintain 1. And then we introduce 3x minus 5y. Difference of two squares. Now, what is a square? Y is a square. What is another square? X is a square. So this is x squared. And this is what? Y squared. Difference in mathematics means subtraction. So this is what? Difference of two squares. This is how we factorize difference of two squares. We maintain the first one, x plus y. And then open another bracket to multiply, then the same x minus y. So this is difference of two squares. It doesn't matter which one you bring first. It may be x minus y first, and then x plus y. So this is difference of two squares. Now, difference of two squares may be used to 1. Factorize expression. 2. Simplify calculation. And then 3. Simplify expression. So let's look at these examples. So 1, we have to factorize this. This is difference of two squares in disguise. So this is 4 squared, which evaluates to 16 m squared minus n squared. Now, this is 4m all squared minus n squared. This is equal to, now this is difference of two squares. So it becomes 4m plus n. Then 4m minus n. So this is the factorized form of that. So let's look at number 2. The second one, we have 81 x squared minus 25 y squared. Here, this is 9 squared x squared minus 5 squared y squared. So this is 9x all squared minus 5y all squared. Now this is difference of two squares. So this becomes 9x plus 5y. Then we have 9x minus 5y. So let us use difference of two squares to simplify this. So this is difference of two squares. So what do we get here? We have 7.64 plus 2.36. Then 7.64 minus 2.36. Now, let us add. When we add this, it is going to give us 10 times, when we subtract this from that, it's going to give us 5.28. So we are multiplying 10 by 5.28. This is going to shift. It's going to be 52.8. Okay, let's look at number 2. So for the number 2, we have 25 minus m squared all over 5m minus m squared. Now, this is 5 squared minus m squared. This is 5m minus m squared. Now, let's continue here. This is difference of two squares. So it becomes 5 minus m. We have 5 plus m. All over, when we factorize m, we have 5 minus m. Now, what do? This is a factor to this one. So this goes into this one, goes into this. So the final answer becomes 5 plus m over m. Okay, so this is also difference of two squares. So it is x squared minus 4 squared all over 3x plus 12. So we factorize this x plus 4, x minus 4. All over, we factorize 3, so we have x plus 4. This cancels this factor. So finally, we get x minus 4 all over 3. Find m. 3m plus 13 squared is equal to 16 squared. So we have 3m is equal to 16 squared. Then this crosses minus 13 squared. 3m is equal to, this is now difference of two squares. So it becomes 16 plus 13. Then we have what? 16 minus 13. So this becomes 3m. When we add this to this, it gives us 29 times, we subtract this from this, gives us what? 3. So 3m is equal to, when we multiply this by this, it gives us 87. We divide both sides by 3. So 87 over what? 3. This goes into this one, goes into this 29. So the m we are looking for is equal to 29. It is important to note the following perfect squares. What's a perfect square? Any number squared or any expression squared is a perfect square. So this is a perfect square, this is a perfect square. So let's look at the expansions of these. It's very important. So this becomes m plus n times what? M plus what? N. So we expand. When we expand, we get what? M into m plus n. And then we bring plus n. Then we have m plus n. So this becomes m squared plus mn. This times this becomes what? Mn. This times this becomes what? N squared. So m squared, simplifying like terms, we have plus 2mn plus what? N squared. This is important. Now let's look at the second one, which is also is equal to m minus n times m minus n. This m into m minus n, then we have minus n into m minus n. So we multiply m times m squared, m times n minus m n. This times this minus m n. Negative times negative, positive n squared. So m squared, this will give us minus 2mn plus n squared. Very, very important. Subscribe, like, share, and discuss with your friends. Thank you.